Hi, I'm Rong and I'll be sharing with you about my final year project, which focuses on the topic of stock price predictability and the business cycle via machine learning. Before I delve into the details of my research, I will share some background. In this research, the term business cycle refers to the periodic fluctuations in economic activity. We will refer to two main business cycle phases, recession and expansion, or non-recession. It is well known that during recession, there is higher volatility in the stock market. There has been numerous papers focusing on developing machine learning models to predict the financial prices of different assets. However, there is little literature discussing the impacts of business cycle on stock price forecasting machine learning models. Hence, my final year project aims to study the impacts of the business cycle on machine learning forecasting models and propose potential solutions to mitigate them. We have two main research questions. The first aims to observe for differences in machine learning performance during different business cycle phases. The second research question focuses on ameliorating any deteriorations in predictions observed. The second aim has three sub-research questions, each exploring different approaches to mitigating business cycle effects. For our experiments, we'll be using a dataset with daily frequency from 1963 to 2022. The feature set consists of the S&P 500 price index, which we will be forecasting, the Fama-French 3 factors, momentum factor, and other features like the VIX index and the risk-free rate. We divided the dataset into 7 overlapping sub-periods to maximize the use of the collected data. We trained the model on each sub-period. Each sub-period includes two types of training data, one with only expansion data and the other with both expansion and recession data. It also includes a validation set and a test set. The following are the rules used to split the dataset. The stock price forecasting problem refers to the machine learning problem of using the last L days of daily features to predict the next day's price index. We used a two-layer recurrent neural network. We experiment with three types of RNN layers, namely LSTM, bidirectional LSTM, and GRU. A recurrent neural network learns temporal information from sequential inputs to predict future stock prices, while a fully connected layer instead reads inputs concurrently to predict stock prices with the following equation. We tuned the hyperparameters of our model with grid search using mean square error as the evaluation metric. In total, we trained 102 models. For the first objective, we compared the recession and expansion test MSEs of 21 models and observed that most subperiods show worse performance during recession. We observed that the exceptions to the observation above were localized to subperiods 73 to 80 and 80 to 83. We then studied the log return standard deviations of all 7 subperiods and observed that across all test sets, recessions had higher standard deviations than expansions. Focusing on the exception subperiods, we noticed similar volatilities between recession and expansion test sets. Upon further research into both test recessions, we noted that the monetary policy implemented during both recessions could have resulted in similar predictive performances during recession and expansion. Having established that machine learning models performed poorly during recession, we aim to improve recession predictions. Starting with the straightforward approach of including recession data in the training set, we compared the performance of models trained with and without recession data and noticed that its inclusion gave mixed success in enhancing recession performance. Next, we attempted to improve recession performance with the incorporation of informative features, starting with the risk-free rate. We observed that this measure also gave mixed success regardless of the inclusion of recession data. Next, we attempted to incorporate VIX index as a feature to improve predictions during recession and noted an improvement in recession performance for the majority of non-recession trained models. However, this trend was not observed in models trained with recession. We hypothesized that this is due to the redundancy of the VIX index in the presence of recession data. The above findings have shown that greater efforts are required to mitigate deteriorating performances during recession. In this section, we attempt to use confidence-based decision-making to ameliorate this effect. Using a autoencoder-inspired design, we generated a model-agnostic confidence score for all neural network models in the form of the reconstruction MAE. We expect the reconstruction MAE to be a proxy for the true error of the prediction. This graph shows the model predictions, MAE, and squared error of our confidence model on 2 out of the 7 subperiods. We observed that MAE and squared error have a highly positive relationship, as MAE and squared error tend to spike together. Using the MAE as a confidence score, we can apply confidence-based decision-making to stock price forecasting. We simply ignore the uncertain predictions, which we defined as predictions with MAE scores greater than the user-defined MAE threshold. Applying this to all subperiods, we notice that with a carefully selected MAE threshold, recession prediction errors could be reduced. This suggests that confidence-based decision-making could be the key to improving model prediction accuracy during recessions. In conclusion, forecasting performances are affected by the business cycle. Machine learning models generally deteriorate during recession due to the increased volatility. We have attempted to reduce its impacts by including recession data and other informative predictors such as the risk-free rate and the VIX index. However, all three measures have had mixed successes. We instead propose confidence-based decision-making as a countermeasure. Using an autoencoder-inspired architecture, we generate confidence scores consistent with true model error. We demonstrate that with a properly selected confidence threshold, errors due to the increased volatility can be managed.